Okay, the exercise at the end of the last video, you were asked to write this function called plot sign. So let's take a look at it. Here's one way to do this. Again, this is a pretty simple function. In this case, you define an intermediate vector. Remember, MATLAB plots vectors, so we actually have to, and I use linspace here, to create a vector with, in the instructions we're told it should have 16 points per period. So in this case that would be, since 2 pi is 1 period, 0 to 2 pi is the range. The period here is actually 1 over f1, 1 over the frequency, and then so 2 pi divided by the number of periods. In any case, if f1 is 1 hertz, then we'll have 16 points over that period. If it's 2 hertz, we want 32 points. That would be 16 per period actually. So x gets longer as f1 increases. But again, to call this function, again, plot sign, we'll try it with just plotting 2 hertz. And the plot actually appeared in another window. So this is what you get with a plot sign of 2. If I recall it with a plot sign of 10, call back the plot. You know, this is what it looks like with plotting a 10 hertz signal over a 2 pi interval. So just a basic plotting function, just an illustration here of how to actually, another example of writing a function. In this case, it doesn't return anything, and then also inside the function I've defined this new variable, and I don't have access to x outside the function. X no longer exists once the function has finished running. Okay, so let's look at a little bit more with programming. So you have, in any programming language, you have the ability to make comparisons between 2 different variables to see, for example, if one numeric value is less than another or greater than another, you can compare them for equality. So some examples here back at is 2 equal to 2, and I get a 1 as a result. 1 corresponds to true. That means the fact that the answer is 1 means that it's true. If it's not true, is 2 equal to 3? That the result I get back from that comparison is no, or false, or 0. Is 2 less than 3? Yes, it is. Is it greater than or equal to 3? It is not, so that's false. One thing that's a little strange with MATLAB is the tilde equal means not equal to. Is 2 not equal to 3? That's true. 2 is not equal to 3. In most programming languages, they actually use the exclamation mark equal to represent not equal, and Octave supports that, but MATLAB does not. So standard MATLAB notation, this represents not equal. So typically here we're comparing 2 variables. It might be, or it might even be a vector or matrix of numbers, in this case, it would be the same as x less than y. I'll get back in the comparison. That is true. Now, the way you use these comparisons is that they are a part of they're also known as conditions. They're part of actually, we use them with decision statements in the programming language, and a bit more on that in just a second. You can also combine these relational operators using logical operators. So for example, is 2 less than 3 and 5 less than 100? Both of those are true. So you know, I get back that that's true. Now for and, both of them have to be true. In this case, the first part of that condition is false, so I'll get back a 0 here. Similarly, instead of the and, there's also an or, which is a vertical bar. With the or, only one of the conditions has to be true. And since 5 is less than 100, this will return 1. For or to return false, both of them have to be false, like in that statement. So in addition to just the relational operators, we've got these logical operators for anding and oring or negating a comparison as well. The all and any are useful when we're doing vector comparisons. All requires that all of the elements be 1. Okay. If any of them is 0, the whole thing is 0. Any, on the other hand, I just need any of the elements to be 1 in the vector. If the only time any returns false is when all of them are 0. Okay. So and the way we typically use that is what's known as an if statement or if decision structure. The simplest is if you know, this condition is true, then carry out this command. Otherwise, a more elaborate example, if the condition is true, then do these commands. If it's not true, do these commands. I can have more complex structures called using else if. Like if the first condition is true, then do this set of commands. Else if this condition is true, do this set of commands. If neither of these conditions is true, then do the commands in the else clause. Now, unlike some programming languages, I don't need parentheses around the condition statement. I don't need braces to delineate my block of commands. The keywords here are used to do that, to mark out which commands I want to execute. We'll look at an example of using an if statement in just a minute when we do the exercise. It's probably a lot more easy to illustrate by example than it is to talk about. The other type of commands that we have are looping commands. For is the best known example. Again, the structure of a MATLAB for loop is a little different than some program languages. Here for n is equal to, then this should be a vector here, and then inside this for loop, n will take on the values 1, 2, 3, because the vector goes from 1 to 100, remember, with this notation. So this set of commands will be executed 100 times in this particular case. And I can use that loop variable n inside the loop. Okay, it is a scalar within the command block. It doesn't have to, you know, I could have a vector of like 2, 4, 8. And then n would take on those values, or even 8, 3, pi. It doesn't matter. The n marks the end of the for loop. Similarly, while is also a looping command, but it also has a condition. As long as the condition is true, we'll continue to loop through with the while command. There's usually something in the command block here that can change the condition so that it's false. Otherwise, we would do the while loop forever, and that would result in an infinite loop. Okay, so let's look at this exercise on how to use conditionals, and since I didn't really show any examples in the script, I'll show you how to do this. It says modify our plot sign function so that it takes 2 inputs now. If it if the number of input arguments is 1, it should do just what it did before. Otherwise, it's going to display the line 2 inputs were given, but then not produce any output, not produce a plot or anything. And then we're given this hint: use the built-in variable nargan, which represents the number of arguments. So here's our plot sign function. I really should modify the help here now. The description, but so I have to modify the function so it takes 2 arguments. And then here, if I call it with 2 arguments, nargan is going to be equal to 2. If I call it with a single argument, it's going to be equal to 1. Now, you don't have to indent these, but it's good practice. Okay. And then you want the block to line, all these statements to line up. So if nargan is equal to 1, it's gonna run just like it did before. If it's anything else, okay, if we call it with 2 arguments, we're supposed to display plot sen was called with 2 arguments. Okay, so again, only one set of commands or the other will be executed. If we call plotsen with 1 argument, it'll run these 2 commands, produce the plot. Otherwise, it'll just, if we call it with 2 arguments, it will actually display this string to the terminal. So let me save that. That's one of the things. So Control S. You want to make sure when you make changes to functions that you be sure that you save them. So if I call plotsen with here, it will actually produce the plot of 1 cycle. Okay, or if I call it with 2, it produces the plot with 2 cycles. But if I call it with like 2, 10 with 2 arguments, it doesn't produce a plot at all. It executes a different section of the code and just displays this. Actually, if I can call it with any number of arguments, and in my code just check to see if nargan was equal to 1, and if it's anything else, it displays this statement. Okay, so we'll take a little break here. It's actually time for our weekly Zoom meeting, but this is just illustrating how to use the if. Here in the author solution, they used else if. If it's equal to 1, do the plot. If it's equal to 2, display this. If for the 3, 4, 5 case that I was playing around with, in this particular case, that would be skipped entirely. Notice there is no else statement here, so there is no else block of commands. So if these conditions aren't true, then nothing in the if statement is actually executed. Okay, so I'm going to stop here. And when we come back, we'll take a look at more sophisticated plotting methods.